Good morning, students. Let's continue the chapter Thermal Properties of Matter. In this chapter, we have studied what is heat, what is temperature, and lastly, we have seen the heat capacity. What is heat capacity? Heat capacity is denoted by letter Q. Heat capacity Q is the quantity of heat which is needed to raise the temperature of body through 1 degree Celsius, or which is needed to decrease the temperature of the body through 1 degree Celsius. If there is change of temperature in 1 degree Celsius, at that time the heat Q is absorbed by the body, or this heat Q is released by that body, and that is nothing but the heat capacity of body. This heat capacity Q is the product of mass of that body into specific heat capacity into change in temperature, and this change in temperature is 1 degree Celsius. So this heat capacity is mass of the body into the specific heat capacity. In the branch of physics which we call calorimetry, we measure the changes in state variable. Which are the state variable? Like temperature, pressure, volume. These are the state variables. For this instant, we are interested in temperature. So in calorimetry, we measure the changes in state variable when the heat is exchanged, when there is exchange of heat between system and surrounding. The device known as the calorimeter is used to measure the quantity of heat which is exchanged, which is transferred from one object to another object. Now let us see a simple calorimeter which consists of an cylindrical metal vessel like this. This cylindrical metal vessel is filled with water about its 2/3 portion. And thermometer, which is used to measure the temperature of water. Suppose this is our thermometer. This thermometer measures the temperature of water, and in addition to this thermometer, there is stirrer. This is the stirrer. With the help of this stirrer, we mix the water so that its temperature become uniform. And this metal vessel, which is generally made with copper, sometimes it is made with aluminum, is covered by an jacket. What is jacket? Which this calorimeter wear. So this is the jacket. The function of the jacket is this jacket does not allow the exchange of heat between the system and its surrounding. So this is the insulating jacket. It is generally a wooden box. This is the wooden box which does not allow the exchange of heat from the system to the surrounding or from the surrounding to the system. The gap between this is filled with the insulating material. Suppose this is the insulating material. The gap is covered by this insulating material. And what is this? This is the insulating jacket. It is generally a wooden box. What is this? This is the thermometer. This thermometer measures the temperature of water. And what is this? This is the stirrer. With the help of when the stirrer is moved up and down, this is the stirrer and the stirrer is moved up and down, then the temperature of the water which is there in this metal vessel is become uniform. This is the this one is the cylindrical metal vessel. The cylindrical metal vessel and the stirrer, they are made with the same material. In our example, that is the copper. Now, initially, the temperature of the water, the temperature of the water, the temperature of this cylindrical metal vessel, which we call the calorimeter, and the stirrer, that is same, and that is the initial temperature of water calorimeter. What is calorimeter? Calorimeter is nothing but this cylindrical metal vessel and the stirrer. This is the initial temperature of this water, the calorimeter and the stirrer. Now let us consider M2 be the mass of calorimeter and stirrer. And let us consider M3 be the mass of water. M3 be the mass of water. We are left with temperature T3, temperature T. We are left with mass M1. We are left with temperature T1. This temperature are not known to you. Okay. Now suppose we are having a piece of sample. Suppose this is the piece of sample A, whose mass is m1. m1 be the mass of sample A, and this sample is having initial temperature T1. Now we are interested to find the specific heat capacity of this sample. For that purpose, we heat this sample to a temperature T1 degree Celsius, which is greater than the temperature of water, the temperature of colorimeter, the temperature of stirrer. So when this sample is heated to high temperature, which is greater than the temperature of water and calorimeter, then its temperature is recorded and that temperature is T1. Then this sample is taken and the sample is inserted in the calorimeter. Suppose this is the sample. Now we put the sample in the calorimeter. What happened? The temperature of the sample is greater than the temperature of the water. Then naturally this sample exchange heat to its surrounding. What is its surrounding? Its surrounding is water, whose temperature is T2, which is less than the temperature of this sample. Then this heat is exchanged to the surrounding, and the surrounding means this water that gained that heat. When that water gains that heat, its temperature naturally increases. And at the same time, the temperature of water is increases. And that when this sample exchange heat to its surrounding, its temperature decreases. Means here this T1 decreases, this T2 increases. The decrease of the temperature, the exchange of heat is carried out for few minutes, and after some time the temperature of this sample, the temperature of water and the temperature of the calorimeter, they become constant, and now this T be the temperature of the combined system. Now this is the final temperature of combined system. Final temperature of combined system means the temperature of sample, the temperature of water, the temperature of calorimeter. Now here the role of this stirrer is to make the temperature of this water uniform. This stirrer is moved up and down. Then the water which is at the bottom, that came to the top, and the cold water which is at the top, that came to the bottom, and that temperature become uniform. So at this stage the calorimeter, the stirrer and this water, they are the gainers. They gain the heat. From whom they gain the heat? They gain the heat from the sample A, and this sample A is the loser of heat. It loses heat. Now let us consider S1, S2 and S3. These are the specific heats of sample. This S1 is the specific heat capacity of sample. One is notation which we use for the sample. So this S1 is specific heat capacity of sample. This S2 is the specific heat capacity of, this 2 notation is used for this M2, mass of calorimeter and stirrer. This is the specific heat capacity of material of calorimeter and stirrer. And this S3 is the specific heat capacity of this 3 notation which we use for mass of water. So this is the specific heat capacity of water. Now, as I was earlier stated that when this piece of sample is inserted in water, then it loses the heat, and the water, the calorimeter, they gain the heat. So the heat which is lost by sample, heat lost by sample is gained by calorimeter, stirrer, and water. And the heat that is not get exchanged between the surrounding, because that calorimeter is having the insulating jacket, and this jacket does not allow heat to exchange with the surrounding, so that heat is remain there. So the loss of heat by sample, that should be the heat gained by the stirrer, calorimeter and water. Now we are interested to find how much heat is lost by sample. Heat lost by sample is Q, and that Q is equal to mass into specific heat into change in temperature, and the mass of sample is M1. The its specific heat is denoted by S1, and del T is the change in temperature. This M1 S1 into del T. Del T is change in temperature. Which temperature is greater? The initial temperature of sample is greater than the initial temperature of the initial temperature of this initial temperature T1. Okay, this initial temperature T1 is greater than the temperature of the water and calorimeter. So here this T1 is greater than T2. This T1 is greater than T2, and this T1 is greater than this T. This T1 is greater than this T, because this sample loses its temperature. This T1 is initial temperature, and this T is the final temperature of that sample. So here the temperature difference is T1. This temperature difference is T1 minus T. The heat gain by calorimeter and stirrer, that should be equal to the product of mass into specific heat into change in temperature. Here the mass of calorimeter and stirrer is M2. Its specific heat is denoted by S2, and here the change in temperature. Now in this case the final temperature, what is final temperature? The final temperature is T, is greater than the initial temperature of calorimeter and stirrer. So here we take the difference del T as T minus T2. And lastly, the heat gained by water is equal to, again, the product of mass into specific heat into del T. Mass of water is M3. Specific heat of water is M3. And the temperature difference is same as that of the case of calorimeter. The water is having the final temperature 2 and its initial temperature is T2. So from the law of conservation of energy, we can combine these three equations and we get the relation between heat lost and heat gain. How much heat is lost? The only loser is the sample. So the heat lost is M1S1 into T1 minus T, and this heat loss is the sum of heat which is gained by calorimeter and stirrer. How much heat is gained by calorimeter? That is M2S2 T minus T2 plus this M3S3 M3S3 T minus T2. This much heat is gained. This much heat is lost. Now we are interested to find the specific heat of sample, this S1. So we rearrange the terms. What we get? M2S2 T minus T2 divided by this M1 and T1 minus T2 divided by M1 T1 minus T2 plus this M3 S3 T minus T minus T2 divided by this M1 into T1 minus T. Which term is wrong here? This T1 minus T, this T1 minus T, and this T minus T2, this T minus T2. Okay, T minus T2. Sorry, here T1 minus T. T1 minus, not T2, but T1 minus T. T1 minus T. T1 minus T. So the specific heat is calculated by using this formula. It is just T. S1 is equal to M2S2 T minus T2 divided by M1 T1 minus T. By using this formula, one can calculate the specific heat. One can calculate the specific heat of the substance. Now we are interested to find the specific heat sorry, here we can combine these terms. What is common here? This T minus T2 is common. So M2 S2 plus M3 S3, and which term is common? T minus T2. This term is common. This term is common. So this divided by this M1 T1 minus T. By using this formula, one can calculate the specific heat of the substance. Now we are interested to find the specific heat of water. What is formula? This one is formula. This M3 this M3 S3 M3 S3 T minus T2 is equal to M1 S1 T1 minus T minus M2 S2 T minus T2. We just rearrange this equation. Suppose this is equation A. We just rearrange this equation to find this S3, the specific heat of water. By rearranging the terms, this S3 is calculated. This S3 is equal to M1 S1 T1 minus T divided by this M2 and this difference in temperature M3 T minus T2 minus M2 S2 T minus T2 divided by this M3 S3 T minus T2. This T minus T2, this T minus T2 get cancelled. What we get? The specific heat S3 of water is equal to M1 S1 T minus T1 minus T divided by M3 T minus T2. So in this way we calculate the specific heat of water also. Now just recall what we have seen. We are started with the heat capacity. That heat capacity is nothing but the heat which is gained or which is lost to change the temperature through 1 degree Celsius. And then we have seen this calorimetry. What is this calorimetry? In this calorimetry, we measure the state variables, and there is an instrument which we call calorimeter, and with the help of this calorimeter we can calculate the specific heat capacity. Its apparatus is here, which consists of generally a wooden box which is called insulating jacket. In this insulating jacket there is an cylindrical metal vessel which we call calorimeter, and there is thermometer, there is stirrer. Okay, and these are the temperatures T1 T2. These are the initial temperatures of sample water and calorimeter, and T be the final temperature. With the help of principle of conservation of energy, we get the heat lost by sample should be equal to heat gained by calorimeter and stirrer, and by knowing the heat lost by sample, heat gained by calorimeter, we get the final equation for this specific heat capacity of a sample. This S1 is the specific heat capacity of a sample, and this S3 is the specific heat capacity of water. I hope you understood this. Thank you.